Here is number 73 in section 2.1. A rancher has 200 feet of fencing to enclose two adjacent rectangular corrals. And here is the figure. We want to write the area A of the corrals as a function of x, and then find the dimensions that produce a maximum enclosed area. So we're looking at a couple of things here. Number one, we have 200 feet of fencing, and so it's really all of the fencing here, which is our perimeter. So with our perimeter, it's just adding all of the sides of the rectangle, or all the fencing. So we have length x and x. We have an x on the other side, two x's on the other side. Then we have our y's. So we can say perimeter equals 4x plus 3y. We want to look at area, and so area of a rectangle is length times width. And in this case, if we're looking at length, notice we have x and x. So the area is going to be 2x, and then width is going to be our y. So what we want to do is write the area A of the corral as a function of x. So we want to write our area. And so what we can do is we can first rewrite our perimeter, the 4x plus 3y. Oh, we also know that our perimeter equals 200. Right, so we do know that number here. So what we're going to do is rewrite our perimeter formula by isolating y so we can use it to substitute into our area formula. So I'm going to subtract 4x from both sides. So we have 3y equals 200 minus 4x, and then we'll divide by 3. So y equals 200 minus 4x over 3. And this is still our perimeter. So we're going to take this perimeter, what y equals, and substitute it into our area formula. So we have 2x, and then our y is 200 minus 4x over 3. So this is area. So what we're going to do is I'm going to go ahead and distribute the 2x inside. So 2x times 200 is 400x minus 2 times negative 4 is negative 8, and then x squared, and all over 3. I'm going to rewrite it in standard form and separate my term, so negative 8x squared over 3 plus 400x over 3. So we're looking at a quadratic, and so a quadratic is upside down, right? And we want to find the maximum area. So maximum area is going to be our vertex. So we need to use our axis of symmetry formula. We basically need to find our vertex. So x equals negative b over 2a. So a is negative 8/3 and b is our 400 over 3. So this is negative 400 over 3 divided by 2 times negative 8 over 3. So negative 400 divided by 3 divided by negative 16 over 3. So we're dividing by a fraction, which means we'll multiply by the reciprocal. So our 3's will cancel, and we're looking at negative times a negative is a positive 400 over 16. And so we'll simplify it, and then 16 times, I think, 5 is 80. So therefore, we find the x value of our vertex to be 25. So we want to find we're finding the dimensions. We found x is 25. Let's solve for y as well. And I think a nicer one to plug this 25 in is to our perimeter formula to solve for y. So I'm going to plug it in here. Y equals 200 minus 4 times 25 over 3 is 200 minus 100 over 3, or 100 over 3 is our y value. And we did solve for our part A, write the area A of the corral as a function of x. So that formula is either this formula here or this formula where it's separated out. Either one is fine. Okay, that equals our area. Now we have our dimensions. We have x is 25. We have y is 100 over 3. Let's actually solve for the area. So what we're going to do is we're going to plug in our x value into the area formula, and we can solve for our actual area, the total area. So 2 times 25, 200 minus 4 times 25 over 3. So 50, and then this is 100 here. So 200 minus 100 is 100 over 3. So this is 5,000 over 3, and it would be feet squared. So that is our area. Now we probably want to convert everything to a mixed number since this is a word problem. So let's go ahead and do that. So 3 divided by 100. So that's 33 1/3 feet is our y. Let's divide 3 into 5,000. Okay, and that's going to repeat. 6, 6, and 2/3 feet squared. So let's finish up the problem by answering the word problem with words. So the dimensions of the corral for maximum area is x needs to equal 25 feet and y needs to equal 33 1/3 feet, and that will be for a maximum area of 1,666 2/3 feet squared. So I hope this helps out.